Hey guys, in today's episode, we're going to go through an exam-style relative velocity question for moving cars. Three cars are approaching the same T intersection. Car A is traveling towards the east at a velocity of 25 meters per second. Car B is traveling at a velocity of 10 meters per second to the west. And car C is traveling at a velocity of 20 meters per second to the north. Part A, calculate the velocity of car A relative to car B. And part B, calculate the velocity of car A relative to car C. Okay, so to solve this question, we're going to be using our trusty guess method. So the first step is to write down all the values that we've been given. So the first thing we want to do is draw a diagram. So we have three cars entering an intersection. We have car A traveling at 25 meters per second to the east. We have car B traveling at 10 meters per second to the west. And we also have car C traveling 20 meters per second north. As you can see, we have car A traveling at 25 meters per second to the east, car B traveling at 10 meters per second to the west, and car C traveling 20 meters per second north, and they all meet at the intersection. Alright, so to answer the question, the next step is to write down what the unknown is. So the question says, find the velocity of car A relative to car B. So that means the unknown is going to be VAB, because we're trying to find the velocity of car A with respect to car B, or relative to car B. So to find out what VAB is, we're going to use our standard relative velocity formula. But before we do that, we're actually going to need to label what these velocities really are in terms of our equations. So this velocity, 25 meters per second, it's relative to the ground. So we're going to just label real quick. This is VAG. It's the velocity of car A relative to the ground. Similarly, this is VBG and this is VCG. Alright, now that we've done that, we can figure out what the relevant equations are for this question. So this is a relative velocity question, which means we're going to be using our standard relative velocity equation. So if you recall from our previous videos, the standard formula is VAB is equal to VAX minus VBX, where X is the intermediate frame of reference and it's usually the ground. In this case, we'll see it actually is the ground. So can you guys figure out how we can find VAB by plugging into this formula? So yeah, you can see it's pretty easily VAB is going to equal to VAG minus VBG. And we have all these values already in our diagram, so all we have to do now is just plug it in, substitute. So we'll do that. We have 25 meters per second to the east minus 10 meters per second to the west. So we're going to have to do vector subtraction to solve this question. So to subtract two vectors, what we need to do is we need to flip the vector with the minus sign in front of it. So if you do that, we can see that we have 25 meters per second to the east plus 10 meters per second to the east as well, because we've now flipped this arrow, now it's going the other way. And now this becomes really easy to add. As you can see, they're both going in the same direction. So all you can do is just add the numbers up and we have 35 meters per second to the east. So we've solved it now and we want to check if our answer actually makes sense. The velocity of car A relative to car B is 35 meters per second to the east. So remember, what does this actually mean? This means what is the velocity of car A if you were sitting inside car B? So let's pretend we're sitting inside car B and we're driving 10 meters per second and this car's coming towards us at 25 meters per second. then it is obvious that the velocities are just going to add together. It is going to look like car A is traveling at 35 meters per second towards you in the easterly direction. So our answer does make sense and we are happy with it. Alright, so part B. Part B is to find the velocity of car A relative to car C. So the unknown is going to be VAC. Okay. Very similar to the previous problem, we can then again use our standard relative velocity equation and go VAB is equal to VAX minus VBX. Remember, we're now trying to find VAC, so we'll put VAC over here and we'll substitute the same values in VAG minus VCG. So now we'll substitute these values in and we can see we have VAG, which is 25 to the right, minus 20 up. Okay, so we have another vector subtraction. This time it's a little bit different because they are going in different directions. So remember, again, to subtract two vectors, we find the vector that has the minus sign in front of it and we switch it with a plus and flip the arrow around. So this is going to end up being 25 to the right plus 20 meters per second down. Okay, now it becomes a vector addition problem. So with vector addition, just remember head to tail, and the answer is going to be from the first tail to the last head. So we have 25 to the right. We want to draw a head to tail. We have 25, 20 down. And our answer will be from the first tail to the last head. So to solve this, we're going to have to use Pythagoras. So our answer for the magnitude will be the square root of 25 squared plus 20 squared. And to find the angle, this angle here, theta, we're going to use our trigonometry. So we can see tan theta is going to be equal to 20 over 25. So that means theta is going to equal to tan inverse 20 over 25. So we type those numbers in our calculator and we get 32 for the magnitude to two significant figures and 39 degrees to two significant figures for our angle theta. So now we want to convert this angle into a compass bearing. So remember, this is east, this is south. Our compass bearing has to start with a north or a south. So the angle that we actually want is this angle. This is the angle that we want. So this angle is going to be 90 minus theta, which gives us 51 degrees. So to conclude, our answer is going to be 32 meters per second, south, 51 degrees east. All right, now again, we want to check our answer and see if this makes sense. So the velocity of car A relative to car C, so that means we're now sitting inside car C. What does it look like the velocity of car A is doing? It looks like it's coming at 32 meters per second, south, 51 degrees east, which makes sense. It's going to look like it's coming at you. So thank you for watching these videos. If you have any questions, then feel free to let us know so that we can answer them for you. Thanks for watching today's videos. I hope that our web series will bring you immense amounts of value for your studies and the HSC. For more information, visit our website synergyhsc.com and stay tuned for the next episode.